Welcome back to Advent of Code 2020. We are today on the day 12, and this is gonna be very interesting because we're gonna have a boat, and we're gonna make this boat sail. We have like directions like north, south, east, west, and we have also another thing on top of that, which is that the boat can go left, right, and forward. So with all of these instructions, we're gonna copy paste that right away. And we're gonna dive and make this boat move. So we're gonna have a class boat, nothing fancy, a constructor, and the constructor is gonna initialize the X and the Y, because the thing is we need in the end to understand the Manhattan distance, which is the position of the boat using this Manhattan distance. So of course we have a X and a Y, but then we need to also have a direction, because this is moving the direction of the boat to the left and this one to the right, so we need to use this correctly. So we need to store something like this dot direction, and we're going to set it 0 equal east. Then we're going to have something that say move. And we're just going to be doing one move for now, just as a simple thing. And we're going to say, actually, how should we say? Yeah, we're going to pass this to the boat. So we're going to say move, actually, no, let's say char and distance and number. So basically we're going to pass f and 10. So we're going to do the parsing outside of the boat. That's going to make things a bit simpler inside this boat class. So now we just have to do a switch. Oops, let's do that right away. Switch with the char, and then we have some cases like going north. We break, of course. And we have a default. It's always good to throw new error. It's always good to write something like that, just to make sure we don't do a weird edge case. So north. Let's start with north. This is not the first instruction, but let's start with north. For north, we're gonna have to go up. The thing is, I'm not sure, we need to understand if north is incrementing 3 units north. So I don't understand if when we move north we need to add something to the position or we need to remove something to the position. East. Okay, so here we move the ship 11 units south. That's interesting. It remains here. Here we move the ship 11 units south to this specific position. Oh yeah, north 3 to south 8. And here we need the... Okay, I think I understand. I understand now. We don't really care about where our axis is, because in the end we use the Manhattan distance, so this is not a problem. We're gonna say going north is gonna add something to y. So this dot y plus equal number. I believe this is what we need to do. Yes, so we're gonna do the same for south, east, west. Let me cut for a second. Okay, so we have our 4 directions. For north and south, we are on the y-axis. For east and west, we are on the x-axis. This is just our internal representation, and it's not going to affect anything. Next up is going to be handling the left, right, and forward. So if we have left, we're gonna have to do, we're just gonna say this dot direction plus equal number modulo 90. And what I'm attempting is like 90 like we can only increment and decrement the left and right in terms of 90 degrees. So if you're facing east and you go left, you just increase by 1 the direction. And we're going to do the same for right. And here we're going to decrement the direction. I'm going to say direction minus equal number modulo of 90. So this means that 0 is equal to east, and then 1 is equal to north, 2 is equal to west, and 3 is equal to south. So now we have a number that is below minus infinity and plus infinity. So we need to make sure this number is in between 0 and 3. So we're going to say this plus, like that. And from that, we're going to say plus 4 modulo 4. And thanks to that, we're going to make sure our number is between 0 and 3. So here we need to say minus plus 4 modulo 4. And this number, at the maximum, it can be 360, which is 4 times 90. So it's minus 4. So I think we're good. We stay between 0 and 3, which is our goal. And here for f, oh, this is going to be a bit annoying. In case we have f, we need to redo one of these. So I can copy paste, or yeah, I think I'm going to actually call the function this dot move, and we're going to say we need to convert the direction to the character. So we're going to say or we're going to create let's create an array here, const direction to I don't know, cardinal, like to this one of these things. That's not super clear, but 0 is going to be e. We're just going to be basically put that into a simple struct. Okay, so here, as you can see, we just like took that and placed that into an object. And now we just have to call this dot move with direction to coordinate this dot direction, and we keep the same number. So yeah, that's gonna help us not having to copy paste this. Now it is time to make sure everything is working fine. New board, boat, sorry. And we need to pass as well these lines. That's quite important. So here, lines for each. Here, this is a line. And we need to split that. So we're gonna do exec. Let's do that. Let's just do a dump exec here. So we have a dot, and then here we have anti/d plus, which is numbers. This is the end of the string with the this is the beginning of the string, and this is the end of the string. We exec that with line. And as you know, I like to name my capturing groups. So this is going to be char, and this is going to be number. Const groups. Let's go to that. Let's console log groups for now, just to make sure we are doing the right parsing. We are day 12. Already 12th day in December. That's crazy. It's going so fast. So something is at null, so we're gonna just console log line. When you have this error, cannot destruct your property groups of, I just display something. Okay, so here this is a typical mistake. I should have moved that to day 12 to make sure I am using this file. And now we have the right line, we have no errors anymore. F10 and 3. Okay, everything is fine. So now we just have to say our boat.move, and we can say groups dot char and groups dot number. And here we're gonna just return something, get position, and we're gonna return math.apps. So this is now we are just doing the Manhattan distance here, and the Manhattan distance is the absolute value of this dot x plus math.absolute value of this dot y. So here we're just gonna console log boat.get position, and we're just gonna run that. We're gonna run everything, and we have. I'm thankful that we have this not implemented thing. What I'm not thankful of is that I should have added here char to make sure we understand what is not implemented. Oof. Not implemented F. F is not okay. So here, as you can see, we have a big issue, is that we forgot the breaks. And this is the biggest issue with switch cases. The switch without a break is really bad. So, okay, we've got our answer here. I believe this is not what we were expecting here, because we are expecting 25, and here we have something like crazy, a huge number. So we're gonna be here, we're going to be console logging the position of the boat each step of the way. Okay. Actually, you know what? We're going to keep that outside, but here we're going to be logging boat.x and boat.y. Okay, so it looks like we have an issue where the numbers are not numbers. So we should make sure we parse int. So this is a danger in JavaScript when you have numbers that are represented as string. When you add them with other numbers, they can become string. I mean, that can be a mess. Okay, so here we made sure that the number is a number and not a string. And now in the end, we have 31. We have 28 and 3. Let me check. So here we have east and north. So let's write that also. Let's use that also at the beginning to make sure we have something correct. So 0, 0, and then we should have 10, 0, then 10, 3. So until here, this is correct. 17, 3 twice. 17, 3 and 17, 3. Then 17, 8. And this is where we have an issue. It's 17, 8 is when we do forward 11. Okay, so forward 11 is not correct. So you know what, let's display here. We have made a mistake here. That's normal because this is the most unclear part of the code. So we say we move east. What? So here this is east, that is correct, but after we rotate, we should move it south. And we're still moving it east. So maybe I made a mistake in the object at the top. Yeah, the direction is staying at 0. So maybe here we miss a parenthesis because maybe modulo is lower priority than the plus and minus. So we're gonna make this parenthesis to make sure, okay, that is not the right, this is not the issue. So I believe here we have an issue with right 19. So this is gonna be around here. So we're gonna be logging a bunch of things here. We're gonna be logging this the direction. We're gonna be logging this as well. And and finally we're going to be logging the full expression. So here I want to debug my mathematical expression, which looks like it is not correct. So we have 0, 0, and 0. What is number actually? Number is 90. So okay, so this is a problem. Actually, I don't need modulo 90 because it's always going to be 0. I need divided by 90. Right? When you have 0, it should be 0, but when you have 90, it should be 1. So that's a basic math mistake here. It should be always divided by 90. Let's try that again. We have in the end 25. This is exactly what was expected of us. So we're going to take the full puzzle input here. I'm going to paste it here and we should be good. I'm going to be removing this here and removing this debug output as well, and we have just, oh, let me remove that as well. We have our 1601 here. That is correct. Let's go to part 2. I'm going to read part 2 first. Okay, actually this part 2 is going to be quite challenging, but I think we're going to make it. And the idea is that now instead of moving a specific to a specific point, we have a vector. This waypoint is basically a vector, so it means that we have a point that we're moving this point around the boat, and then when we move forward we go to this point and we go along the direction pointed by the point. And now it means that these two things are going to be a lot more challenging to rotate a waypoint around the ship, left or right, because now we have to rotate a specific vector. Previously the vector was just 1 in one direction. That was easy. Now it's going to be not 1, so that's going to be a bit harder. And for that I have found this very useful formula, which is going to help us rotate a specific vector. So that's going to be very useful. And we're going to be, I think, creating a more advanced boat, because this boat is not gonna help us. So we're gonna say better boat. That's gonna be more helpful. And here this is gonna be dx this.dy equal 0. So this is gonna be our better boat. So let's just const better boat is equal new better boat. We're gonna still have a function move, and we're gonna have a function get position that I'm just gonna copy paste. That's fine to copy paste once. Here this is gonna be char, and here this is gonna be number. So one thing is that most likely we're going to be we're just going to be copy pasting that as well. And here we're going to be moving our better boat, and in the end we're going to be logging our better boat. It's nothing crazy for now, but now we're diving into this here. And we still have north, south, east, west, left, right, forward. So I think it's fine to copy paste that, especially because we don't want to miss the break here. However, here this is going to be dx dy dx dy, and here we are going to have to do this rotation. So we're just going to copy paste that. I'm not sure actually that's going to be doing fine. Oh, it looks like this is doing okay. So here const the angle. So let angle is going to be something like when we move to left. What is left? Left is counterclockwise. So it means this is going to be 90 here. wait, no. This is something that is going to be given to us. So left here, yeah, I think, let's check our pattern input here. Let's see when we have a left 90. Okay, so I think for left, it's not a problem. We're just going to be able to use this function correctly, but for right, we're going to need to use minus the angle provided here. And here, what I want to check also is in the JavaScript, math, cosinus and everything, that kind of stuff. I want to check if we need an angle in, okay, no, the angle must be in radians. So, okay, let's do like if it was radiant already. Let angle is equal to number. So here we need to say this dot x, oh no, let's say let x is equal to math dot cos of, okay, let me read this formula. Oh, is that this is the angle that we need to rotate, right? Yes. And here I think this is going to happen outside the cosinus, right? Yes. Okay, so that was a bit misleading. So here we're going to be doing this dot x times math.cos of the angle minus this dot y times math.sin of the angle, sinus of the angle. So here really there isn't crazy thing. We're like taking this formula right from textbook, I would say. This is sinus now, and this is a plus with cosinus. The one problem is that here our angle is in degrees, so we need to divide by 360 and multiply by 2 times math.pi. So so it would be, so we just have to divide by like that. Yeah, that should be good. That should be good. So here what I'm worried is because we're using cosinus and sinus, we might be hitting approximation errors, meaning like floating point errors. And here the angle, if I remember, I said this should be minus the number. So we're like doing exactly the same thing, except here we minus the number. I think it's time to, no. It's almost time to try this out. Here we need to do the move. So to do the move, oh, wait. I forgot something. Here we need to say this dot x is equal to this new x, and this dot y is equal to this new y. And we need to do the same here. And then here, what do we need to do? We need to, this dot x, oh, here we are not working on x and y. Here it says clearly that the rotation is, we're rotating the waypoint. So here, this, everything should be dx instead of being x. That should be better. So I've replaced all the x's by dx and all the y's by dy's. And now we can do the proper this dot x plus equal this dot dx. And this dot y plus equal this dot dy. So that sounds fine, but you know, we need to just run this and see what happens. Okay, angle, okay. Oh yeah, one thing, I don't know if we can make things like that. Oof. So what I'm thinking, the problem is that we are defining some let here in this case, and that's a problem. So we are like gonna make everything inside a block. I believe that should be fine. Okay, except this little issue. So I think we're gonna need to do a math.round here. Math.round, and basically we should always land on a round digit. So using the math.round is gonna make sure we always land on round digits. 221, is that the answer? We'll see that right away. That's not the answer. The answer is too low. So I think it's time to go back to these small examples. Like always, when you face an issue, you just go back to a simpler use case. You run it. Here I'm finding 6, and I should be finding something much bigger, right? Yeah, 286. So we're having an issue. Oh yeah, I think I didn't do a right job with F here. We need to move forward to the waypoint a number of times equal the given value. So here, this should be plus equal number times this. Here and there. I think that's a better way to understand the prime statement. However, we are still not good. 54, and we should have like something bigger. So that's fine. You know, we're gonna do like in the previous step. We're gonna be showing the position of the boat each step of the way, and that's gonna help us debug this mystery. We start, okay, the waypoints start at 10 units east and 1 unit north relative to the ship. So that's one thing that I didn't do correctly. So it starts at 1 unit north here and 10 unit east is plus. So okay, let's try that again. Now we have 286. This is correct. So you see, when you go back to a simpler input, you direct things one by one. It is super helpful, because in the end it's really about debugging these little things, finding the problem, patching it, and then finding the hopefully correct solution. And it is the correct solution. Thank you very much for the support in this series. Please drop a like, and see you in the next one. Bye bye.